Hey everybody, welcome back to another fun and exciting pre-calculus class. Today we'll be on page number 23 in your book, and that is lesson 2.5, solving right triangles. And maybe you're thinking, I've already done this. I know how to solve right triangles. I know the Pythagorean theorem and blah, blah, blah. Well, let me challenge you here to just really pay attention to this lesson because sometimes they don't give you enough information to use the Pythagorean theorem. And so we have to solve it using different methods. Let's go ahead and look over here at the book, and we'll take a look at some different steps, if you will, to solve a right triangle. Step number 1. Draw an accurate diagram labeling all parts and the given. This is key, and if you had a geometry teacher that really kind of knew what they were doing and helping you, and I'm sure that you did, then one of the things that they told you in geometry class is draw the triangle. Get the triangle down onto the paper. All right, and so that's where we want to start here as well. Get the triangle down onto the piece of paper, label it, make sure that you label the C angle, make sure you label everything else in the places where they go. Number 2, make a table of the unknowns. What does that mean? Well, write down your unknown parts. Like if you're looking for angle A, write A. If you're looking for side, well, capital A. If you're looking for side A, then write a little a. And you can write like a question mark next to it. You can write a blank. You could write, whatever you want there to kind of help you to remember, oh, I've got to find that. That's part of my solution. Number 3. Write an equation containing only given values and one unknown. In other words, we're going to take these one at a time and we're going to try to figure out what these are. Once we get one, then we can move on to the next one. Okay, so one at a time. Number 4, solve that equation for the unknown, insert given values, and calculate. Notice what it says right here, and this is actually really, really important. So notice what it says right here. Avoid using calculated values when possible. I'm going to highlight that, okay? And it is important. And why is it important? Because if you continue to use calculated values over and over, then your answers, let's say you find A and now you need to find B. Well, if you use the calculated value for A in the solution for B, you're going to be farther away from the actual value. So in other words, you're losing accuracy the more and more calculated values that you use. Number 5, repeat steps 3 and 4 for each unknown. You just keep going back to steps 3 and 4. And then number 6, you can always check your solutions. All right, let's turn the page over to page number 24. Now that you kind of have those, I'll keep going through those in a way. I don't know that I'll keep coming back to this page, but I might. All right, let's come over here. And what I've done is I've taken each letter. I've basically done step number 1 and step number 2 from the list of steps that they gave you. So I took and I drew my triangle, all right, and I labeled it the same way that they have it labeled. What is one reason why we do this? Well, one reason why we do this is because it helps us to just visualize it as we're going through it. We don't have to keep going back and forth to the book. Some students like to cut this step out. Let me encourage you not to cut this step out because this is an important step in helping you to kind of your mind just to wrap around the concept. When you take your pencil and you draw the triangle, it is helping you to understand what's going on. When you just look at the book or you just look at a video screen, you are not going to get the same experience. You're not going to have the same learning taking place. There are studies that have been done over and over about how important it is for you to take your pencil and you to actually put on your paper the information that's on the screen or in the book. And so if you'll do that, I think it will help you to learn this more and more. All right, so here we go. I've got my representation. And now what I want to do is I want to input the information from page 24. So A, side A, okay, it says that it is 33 degrees, or actually angle A, 33 degrees. So I could come out here and I could write 33 degrees here if I wanted to. I don't necessarily have to there, but it maybe does help you just a little bit if you're actually putting it into the picture as well. Notice what I've drawn over here is I've really drawn my table of the things that I have, the given and the needed information. So we're just going to put the given, and then everything else will be needed information. So side B, it says, is 23. That's 23.0, but 23 is the same thing. Now, another one that we can always fill in right here is this one is always going to be 90. We always know the C angle is going to be 90 because it is the right angle right over here, okay? All right, so if you notice, we're missing one value, two values, three values. That's what we're missing right here. So that's what we need to figure out. So we're going to have to do this problem 3 times in order to get all 3 values to work out. Now, some of you might be looking at this saying, I'm just going to use Pythagorean's theorem. Well, there's a problem. You only have one side. We don't have 2 sides. So the real question is, where do you start and what do you do? So I could put in this B side is going to equal 23. So one place that we could start is by looking at, we have the reference angle A, and we have, notice we have the adjacent to A. So what do we have? If we have an angle and an adjacent, let's say that we're looking for, let's start by looking for the hypotenuse. How could we do that? And again, this is where you kind of got to connect these dots. What have we learned about trigonometry so far? Well, we have learned how to get, if we have the angle, we've learned how to get the sine by plugging it into the computer, or into the calculator, or the computer. We've learned how to do some of this stuff. So notice, if we have, if we're looking for, we have the adjacent, and we're looking for the hypotenuse, and we have the angle, we could do the cosine of 33. So if we could do the cosine of 33, what does that equal? Well, it equals the opposite over the hypotenuse. What is the opposite? The opposite is B. The opposite is 23 over, this is the one that we don't know. C is our x. That's what we're looking for. Our hypotenuse is our unknown in this one. All right, so there's my equation. All right, so now I just need to solve that equation. Well, how do you solve this equation? Using algebra. How are we going to do that? We're going to move x to a side all by itself. The way that you do that is you are going to multiply both sides by x, and that's going to cancel that x from that denominator, and so you have x over here. Okay, so you have x cosine of 33 equals 23. Now what we would want to do is we would want to divide both sides by the cosine of 33. And then we would also divide this 23 by the cosine of 33. All right, that's going to cancel that off of that side. So what are we going to be left with? X equals 23 divided by the cosine of 33. Okay, now notice here, we've gotten x by itself. X is all by itself over there, and now all we need to do is this math right here. Once we do that math, we will get the answer. So let's jump over to our calculator, and let's go ahead and do that. So we're going to do 23 divided by, and you're going to divide that by the cosine. So hit cosine and then 33. And we can close that parenthesis and just hit equals. And we're going to get 27.424. Now notice again, we have to round this off. Why do we have to round it off? Because it didn't give us an exact value. So here our x, and let's go back to what is our x. First of all, let's write it in. So x equals 27.42. We'll just put 0.4. So 27.4. Now this is not correct. It's not exact value, so we're going to have to put our bacon sign on there. So our x equals 24.7. Well, what was our x? What were we looking for there? Our x was our hypotenuse. We were looking for, because we used cosine, so we used adjacent over hypotenuse. This was our x. And if you want to use h there, that's fine, or little c, you can use that, if that helps you to keep in your mind which side you're looking for. So our c, our small c, is approximately equal to 27.4. So now we're going to come back up here and we're going to put our 27.4 for our c, 27.4. Now, some of you might jump to this right now. So you're saying, okay, c equals 27.4. Okay, well now I can use Pythagorean's theorem right here. Well, let me caution you on that. Let's jump back over to the book here and notice what it says. Avoid using the Pythagorean theorem here to solve for side C. Or in our case, we found side C at the beginning, so to solve for side A in our case, because this would require using one calculated value, value A. In other words, we would have to use a calculated value or an approximated value in order to find side A, so we're going to steer clear of that. We're going to go back and use our trigonometric functions again. Well, let's kind of do something here real quick, and this will be, some of you maybe were thinking, I wish you would have done that first, and maybe, maybe I should have. But one thing that we can find immediately is side B. We can always find, if there's two angles, we can find the third angle, and this doesn't take a whole lot of calculation. This just takes, because remember, we have A plus B plus C equals 180. And since C always equals 90, we could just subtract 90 from both sides, and we could say that A plus B equals 90. Okay, remember this? So now what we can do is we can substitute A in, and A is 33. So 33 plus something equals 90. We would subtract 33 from both sides, and it would come out with B equals 67. B equals 57, sorry. B equals 57. I subtracted it from 100, but subtract from 90, 57. Okay? So there we go. Now, notice that B is not a calculated value. So let me go ahead and let me put little squiggly lines on this C, and I'm going to put them in a different color so that you can see them. Why am I saying that? Why did I put those squiggly lines? Because we can't use C anymore. C is out, okay? In other words, as soon as we find this approximated value, we don't want to use C anymore. We don't want to use the hypotenuse anymore, okay? So what we need to do now is we need to say, okay, I'm looking for A. That's my missing side here, so what do? C is the only one you cannot use because it's an approximated value. So now B is not an approximated value. Now we calculated B, but we calculated it to an exact value because this was a whole number and 90 is always a whole number. What if A was an approximated value? Then we couldn't use B. You can only use the ones that are not approximated. Okay, so if we're looking for A, let's come over here, and we could even put B on here if we want to. That's 57 degrees, okay? Now, one thing that we could do is we could use angle B if we want to, or we can use angle A. It doesn't matter here in this case. So if we use angle A again, we could use, what do we have? We have A, that's what we're looking for. That's our X now. That's our missing value still. And we have B. So we have the opposite and we have the adjacent. What trigonometric function uses opposite and adjacent? That's right, tangent, okay? So we can use the tangent of, and then we used A, and you could use tangent of B as well, it doesn't matter. But we're going to use tangent of A, so tangent of 33 equals opposite, that's our X this time, and then let me just put O up there. So we'll solve for the letter O. Maybe that will help you to be able to see that. Over the adjacent, B is the adjacent to A. All right, so we're looking for the opposite. This is our X, and this is I mean, it's a little bit confusing because you're like, no, it's the A side. I know it's the A side, but it's not the adjacent, okay? And so that's why I don't like to use O. So you know what? I'm not going to use O. You try to convince me to use O, but I'm not going to. All right, so I'll use X right there. All right, and so we want to put the opposite, which is A, or our missing side, over the adjacent, which is B, or 23. And now we need to solve this, okay? Now again, the way to solve this is just to multiply by 23, both sides. That's going to cancel here. And this one's just going to be a little bit different because we don't have to move anything else because look, we already got X by itself. So all we have to do is go to our calculator and we have to do 23 times the tangent of 33. So hit tan of 33, close those parentheses, hit equal. We get 14.936 or 14.9. So X equals 14.9. What was our X? Our X is our A side, and so our A side is going to equal 14.9. It was right down there, 14.9. Okay. 14.9. Now, very important, again, get rid of that equal sign because A does not equal that. A is an approximate value. Now, you might say, okay, so I've got that. I kind of followed that, but how would you check that? Well, the way that you would check it is you would just plug in to any trigonometric value or to the Pythagorean theorem, and you would just verify that these actually do equal that. Now, if you use Pythagorean theorem, remember that these are approximated values, so your Pythagorean theorem is going to come out almost exact. It's going to come out really close, but your calculated value should be within hundredths or thousandths of each other. And if they are, then you'll know that you did it correctly. All right. The next example, and I'm not going to take time to go through the whole thing, I'm just going to kind of talk through it, is on page number 25. So let's look over there real quick. Solve this right triangle. Now this time, okay, and we're going to do the same process, but it's going to look a little different. So this time they give you different information. What do they give you? They give you this time the C value. They give you the hypotenuse, and it's 7.65. Okay. They also give you, that's right there, 7.65. Okay. They also give you the B side, and the B side is 4.58. Now, I want you to notice something. Those are not approximate values. So let's jump back over here. And I've put those in. I've populated those here on our little chart. I've got our triangle drawn. You're supposed to draw that. It's going to help you. Please do it. Notice that these are not calculated values, so we can use those. What can we do here? We can actually, since we have B and C, we can find A using Pythagorean's theorem. A squared plus B squared equals C squared. We can actually use that to find A this time. We always know that C is going to equal 90 degrees. And so if you look back at the example in your book, it tells you once they go through, you can see where it went through Pythagorean's theorem, we get 6.13. So A equals 6.13. Now it doesn't equal that. It is approximately equal to that since we did use an approximate value in the Pythagorean theorem. Well, our solution was an approximate value. We rounded off. Okay? So now what do we do? And this is the point that I really wanted to show you, because now it's like we don't know these angles up here. We don't know. Well, what you do is you put them into our formulas. What's our formulas? Our trigonometric formulas. So if we know, let's start with B. Let's look for B. So if we know all the sides, we can use any of the three. We can use opposite, adjacent, or hypotenuse because we know them all. Now, the one that you don't want to use in this case is the A value. So in other words, this one's out. Why is it out? Because of its approximate value. So that guy's out. So let's go back and let's do this. Let's try to solve this without using A. So let's use B and C. So if we're going to find angle B and we're using B and C, we have the opposite and we have the hypotenuse. Which one uses opposite over hypotenuse? Okay, that's right, sine. So we're going to do sine of B, because that's the angle we're looking for. This is our x. Okay, this is our question mark, equals opposite, which is 4.58, over the hypotenuse, which was 7.65. Now we just solve that. You say, how do you solve that? Well, you take your calculator and you just do this. That's all you have to do right here. Okay, and so you just go ahead and take your calculator out, and let's clear this out. Let me move them over here so I can see the values. Okay, and so we're going to take this and we're going to say, now remember, we're not looking for the sine of B, we're looking for the angle. So how do we find the angle? We find the angle by doing the shift sign, or the sine -1, the inverse sine of what? Of this right here, 4.58 divided by 7.65. Close that parenthesis, hit equal, and our angle is 36.77, or 36.8. 36.8. Let me put that in white so you can see that better. 36.8. Now, again, we have an approximated value. We can't use that. Now, this is where students go wrong a lot of times. They're like, oh, now I can just subtract this and I can get my other angle. You can't subtract that. Why not? Because this is approximate. So what you have to do is you have to go through that same process for A. So you need to go over here to A now, and you need to use B and C. What's B and C? B and C is now the adjacent and the opposite. So now you need to use cosine, and that will give you your third angle. Okay? I'm not going to go through it. It's there in the book. I'll cut the video off here. If you have any questions, go ahead and rewind it. I know I'm unpacking a ton for you right now, but I think if you practice it, I think if you watch the video, I think if you use your hand, you write, you follow those steps, I think you can do this. So be patient with it. Take your time. Work through these. At no point in trigonometry, at no point is there an easy question, just so you know. Every single question in this trigonometry calculus class is going to be rather involved. There's one of your tests down the road a little ways. The test only has 7 questions on it, and typically it takes students over an hour to finish those 7 questions. Okay, so I'm telling you that to help you to understand that these questions are not going to be simple in this class. These questions take a long time to figure out. You're not going to be able to do 20 problems for homework. That's not going to be realistic. So you have to work through it. Take your time, work slowly. It's about understanding the process. It's about understanding the steps. So make sure that you are doing that. Okay, if you have any questions, slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.